Problem. Two circles, moving, collide, maybe. Discrete? Boring. Moving. Moving fast. Low step rate. What? More step rate. Stupid. Silly even. Solution? Continuous. Continuous how? I'll tell you. Circle 1 moves. Circle 2 also moves. They collide after t. Must find t. Position vector plus velocity vector times t. Point A. Position vector plus velocity vector times t. Point B. Distance between point A and point B. Radius 1, radius 2, radius sum. Collision. Collision when radius sum equals distance. Distance between point A and point B equals sum of radii. Expand. Solve for t. How? Not telling you that. Naive solution. Expand magnitude. You do the rest. Simplified. Quadratic equation. Awesome graph. Collision when t is 0. Oh, I know. Give up. Quadratic formula. Oh, yeah, quadratic formula. Silly quadratic formula from silly high school. Ah yes, it was useful after all. Solve for t. 2 values. But 2 values how? Collision 1, theoretical collision 2. Ah, so I'll only take the lesser t. Careful. T can be negative. T negative? How? Collision backwards in time. Ah, so I'll only take the lesser positive t. No. If circles are overlapping, one t will be negative and the other will be positive. Second collision is always theoretical. If considered, overlapping circles will never separate. Ah, so I'll always take the lesser t, but only consider it when it's positive. Correct. And then he went on to forge his perfect continuous collision handler. But hold on, what do I need t for anyway? Simulation is discrete. Time step, 0.1. Current step, next step. Continuous collision check, t is less than 0.1. Step simulation by t, handle collision, step simulation by remainder of time step, collision, continuous collision. Thank you for watching, leave a like, do not subscribe, my regular content isn't similar to this, goodbye.